Many different kinds of ethics were discussed in the video you saw before, and you might be wondering, what kind of ethics will we study? We're going to talk about that right now. The most important thing we'll talk about is who is a professional and what is expected from you in terms of professionalism. We'll also talk about responsibility. What is your responsibility? How do you decide what it is? And most engineering decisions come with certain risks. You have to balance those risks. How do you balance that with economics, especially in the workplace? Also, you want to know what you're legally liable for. We'll also look at issues like what is confidential information and what is whistleblowing? What kind of information can you share? What is expected of you? And also issues like what if there's a conflict of interest? If there are two different things that need to be done and they are in conflict, how do you proceed? What kind of decisions do you have to make so that they are ethical? Many of the engineering ethics case studies look at large issues, like, for example, the Challenger disaster, or the Chernobyl disaster, or a bridge collapse. But there are also mundane everyday issues that you encounter when you're not making large scale decisions, but there's still decisions that you have to make as an individual. For example, can I accept gifts? Or should I give a gift if it's expected, particularly in another country or another culture? Or it might be something that's related to your job. Can I share information? What if they ask me confidential information about an old employer? Or they ask me to build something I learned when I worked at a competing firm? There might also be issues such as what do I do if a family member asks for a favor? What do I do if it's my boss? Or can I do myself a favor? For example, say you're moving soon into a private company from a state government job, and that company has submitted a bid to your department in the state government. Should you be the one making the decisions? Or issues like moonlighting. Can I take up another job? This is not an issue for specific kinds of jobs like cleaning, where you would just go in, do a job, get paid for it. When you're an engineer, people depend on you for your professional judgment. Your other job could bias you. So these are important issues. So we will be looking at big issues and small issues. In the next slide, we will examine what those issues. We will also look at case studies. So for example, we could examine the Challenger and the Columbia disasters and understand how small lapses like not informing astronauts about the behavior of O-rings when the temperature goes down can lead to disaster, or not examining the consequences of a foam strike on the wing of the Columbia can lead to the loss of the space shuttle. We'll also examine case studies where individuals within companies decide to act, and that has ethical consequences and impacts for the general public, like the example of the Goodrich. Sometimes the large issues are global in character. So for example, when we talk about climate change and global warming and what kind of new technologies engineers should develop for energy resources, we could actually have a cost-benefit analysis that looks at whether a specific technology like biofuels is ethical. Or you could be talking about small issues like whether you should be using grade A bolt or grade B bolt and which would be safer. Or you could be talking about whether you can accept a gift or you can give a gift to the head of an engineering firm when you go into a new country and you are bidding for a contract. Let's start by looking at an example that has global consequences. If you're not familiar with the Hadron Collider, it is a facility that is designed to speed protons, the building blocks of ordinary matter, to energies of 7 trillion electron volts. They then crash them together to produce tiny fireballs. The idea is to create miniature versions of the Big Bang. Right. The issue involved here relates to whether you can ethically decide that you're going to undertake something like this, while most people actually don't understand what the consequences are. The Hadron Collider is located near Geneva. It is an underground facility and it was built by the European Organization for Nuclear Research. It's controversial because there is a small probability that this facility and this experiment could result in a black hole that would swallow the Earth or could create some dangerous particles. There was a safety group which did some analysis and came back and said, based on what we know so far, the theory points out that cosmic rays that are equally energetic have been produced before naturally, and they have collided with the Earth, and we are okay. So it's all right. The controversy for people who are critical about this experiment is this. It's a theory, and you're testing it out. We have no way of proving it one way or the other. And we are taking a risk. Even if it's a small probability, it is still a risk. And you're talking about 6 billion other people on Earth and the entire universe, which could actually vanish into this black hole. And the question is, well, you as scientists and engineers have to then actually make a decision. You're basing it on some theory that you understand, but it's not been proved. And there has been no large-scale discussion asking people for informed consent. The rest of the people who are out there, the 6 billion other people, have not actually had the opportunity to think about this risk and give you consent so you could go ahead and perform this, because it is indeed taking a risk on their future. So it's not just about you, the scientist and the engineer, taking a risk for your work and yourself, but it's for the livelihoods of the rest of the people who live and share this earth and this. Another large-scale issue where science and engineering data also has significant ethical dimensions is related to global warming and climate change. This was illustrated in a very dramatic manner recently with the cabinet of the country Maldives holding a cabinet meeting underwater. And they did this to illustrate that if nothing is done to curb emissions of greenhouse gases such as carbon dioxide, then by 2050 the island of Maldives will be underwater. Maldives is not alone. There are other island countries such as Fiji and Tuvalu and Haiti which will be affected by global warming and they will sink. Now, Maldives has a population of 300,000 and most of these island countries have no big industries, so they emit microscopic amounts of greenhouse gases as compared to, let's say, the United States, which emits 25% of all the greenhouse gas emissions. So they argue countries such as the United States should do something about greenhouse gases. Now, one solution proposed here in the United States is called geoengineering. Now, engineers have come up with many strategies for how they would go about doing this. One involves putting sulfur aerosol particles out into the atmosphere. The other involves putting iron into the oceans. As you can see, these will not be confined just to the United States. If you put something up in the atmosphere and you're cooling large land masses like Asia and Africa, you are talking about affecting millions of people in those continents. If you have something that you put into the oceans like iron, you're also talking about affecting fish supplies, affecting the health of the ocean, not just in the coast of the United States, but also with all the other countries that share a coastline with the Pacific Ocean. So not only is emitting greenhouse gases an ethical issue, it's also an ethical issue when you're talking about how we're going to fix this. Do we have engineering solutions? How do we go about curbing emissions? Who has to make what kind of sacrifices? So you can see there are many, many ethical dimensions to an issue like this. But in this class, we're also going to talk about small issues. Like, for example, I am an engineer and I have to build a scaffolding. I have a budget and I know how much money I have to spend on getting bolts, for example. So what do I do? What kind of bolt should I use? It might be that technically you might have to use one specific grade of bolt, but that might be very expensive. And you might actually think about, can I make some trade-offs? What kind of bolt should I use? Now, those are equally valid, and we're going to be talking about those in our class too. Let's take a look at another example. This is the Bhopal gas tragedy. This is an industrial disaster that took place at the Union Carbide pesticide plant in the Indian city of Bhopal. At midnight on December 3rd, 1984, this plant released 42 tons of toxic methyl isocyanate gas. It exposed 500,000 people to the MIC gas and a bunch of other chemicals. So the first official death toll confirmed by the government was 3,787 people dead. And within 72 hours, 10,000 more were confirmed dead. So what were some of the factors that led to this gas leak? Some of them were basic things like storing chemicals in large tanks instead of over 200 steel drums because it was just economical to store them in large tanks. There was poor maintenance. They found corroding material in the pipelines after the plant ceased production in the early 1980s. There were also failures of several safety systems, and these safety systems were actually shut down to save money. So, for example, the methyl isocyanate refrigeration system was shut down. This alone could have actually prevented the disaster if it was operational, and economic concerns just prompted them to shut the safety systems down. Some of the other factors leading to this disaster are related to the kind of manufacturing methods that were employed. There was a dangerous method for manufacturing pesticides that was employed. They also did large-scale storing of the toxic gas before processing it. They chose a location that was close to densely populated areas and depended on manual operations for safety procedures. So now you have a pretty good idea of the kinds of ethical issues related to technology and globalization we will be talking about in this class. There are interesting questions here. So what was Union Carbide's liabilities other than what happened in 1984? What about the continuing environmental devastation? Do they have to pay damages? And who's going to pay for it? There are also issues about the kinds of safety measures that Union Carbide had in place. If they had established a plant in any other country, they would have actually had to follow safety rules. They claimed that they were making sure they followed all the rules in India. However, the regulations were almost non-existent. So what was Union Carbide's professional responsibility? What were the engineers' responsibilities? Were they operating safely? So these are some of the ethical issues that we need to consider in a situation like this. If you go to a foreign country, what laws do you follow? What is your responsibility? Ethically, how do you ensure safety?